So the last time I tried to record this, it didn't record any audio, so I'm redoing it. This is page 74, the example in the middle of the page, which describes adding HCl to a buffer solution. And just so you can get your bearing, it says, consider the effect of adding 1.0 milliliters of 1 molar HCl to a 1 liter of a buffer that contains, and so forth. So this uses you can use the Henderson-Hasselbalch equation because it's a buffer, so you can avoid an ice table. So I used it here, and I got the Ka from a table, and these conjugate base and acid concentrations are given in the problem. You get 0 here, as it turns out, and so the pH equals 4.74, which interestingly is equal to the pKa. So then you add the HCl. The question is, how does that HCl react in the water? And it doesn't react with the water, it reacts with the base because it prefers to react with the base than it would rather react with the base than the water. Because it's an acid and that's a base, and yeah. So here's the reaction. The initial concentrations are given. You might wonder where this 0.001 came from. So I explained it. I actually apparently erased the explanation, but basically the idea is that you can think of all of these as concentrations or as moles, because it's 1 liter. In the end, if you look at the problem description, it says that this is a 1 liter of buffer, so it's convenient because molarities and amount of moles are going to be the same number, except for the HCl. You're given for the HCl that it's 1.0 milliliters of 1.0 molar HCl before you put it in the buffer solution, which means how many moles of HCl is that? 0.001 moles of HCl, because 0.001 liters times 1 mole per liter equals that. So when you mix that in, now it's 1 liter of stuff, which includes 0.001 moles of HCl, and more formally you can do the dilution equation if you want, or you can just be like, okay, it's 0.001. But if you did really want to do the dilution equation, it would look like this. So this is 1 molar times 1 milliliter equals 1, we don't know them, M2, and then the final volume is 1 liter, or 1.001 liters if you wish, because you added a little bit of liquid. Doesn't matter. And you get M2 equals that ish. So that's where this comes from. Knowing where that comes from, you have this initial. Now that I'm going to go back to my table. So we have the initial of all 4 of these, and then all of it reacts. That means that at the final HCl concentration is 0. The final C2H3O2 minus, it goes down by that much because that reacted with that, and so it went down to that. And same story over here. It reacts, the reaction happens, this goes up, and now we have numbers to use in our Henderson-Hasselbalch again, which is seen here at the bottom, and that's it. You get a pH 4.72 instead of 4.74, and so the buffer was successful in slightly lowering the pH.